So in this problem, we're asked to prove this relation about cross products. The derivative with respect to time of A cross B is equal to the derivative with respect to time of A cross B plus A cross the derivative with respect to time of B. So in order to do this, I'm going to first separate A cross B into its components. So A cross B is equal to x hat times a sub y b sub z minus a sub z b sub y plus y hat a sub z b sub x minus a sub x b sub z plus z hat a sub x b sub y minus a sub y b sub x. So now, of course, we have to take the derivative of this. D by dt of a cross b is equal to the derivative of each of these unit vectors with respect to time is going to be 0 since they're constants. So we get simply x hat times ay dot bz plus ay bz dot minus az dot by minus az by dot plus y hat az dot bx plus az bx dot minus ax dot bz minus ax bz dot plus z hat ax dot by plus ax by dot minus ay dot bx minus ay bx dot. So there's quite a bit of algebra here. So now we're going to separate these out into the a dotted terms and the b dotted terms. This is going to give us x hat times ay dot bz minus az dot by plus y hat times az dot bx minus ax dot bz plus z hat times ax dot by minus ay dot bx plus the b dotted terms, which is x hat times ay bz dot minus az by dot plus y hat times az bx dot minus ax bz dot plus z hat times ax by dot minus ay bx dot. And, of course, no surprises here, these two terms are exactly equal to these two terms right here. So as you'll notice, all of the a terms in this top one are dotted, and they form a perfect cross product. So this top term is d by dt times a cross b. And the second one is a little bit harder to see, but all of the b terms are dotted, and they're exactly the same terms as above, in exactly the correct order. So this is added along is a cross d by dt of b. So it's not a very complicated proof, but a lot of algebra that you have to do. It's very easy to mess things up. I wouldn't be surprised if I miswrote at least one of these terms, but this is basically how this proof is going to go. And it is a very useful formula. I'm sure if you work with cross products long enough, you're going to use this quite a lot.